Okay. Testing. Oh. I'll be right back. I'm going to check the audio on a separate computer. Oh, you guys can see that. Testing voice. Algebra 1, Algebra 2, Geometry. Alright, there's a bit of background noise, but hopefully that doesn't cause too many problems. I'll keep an eye on the chat. If you ever need a question, just type it in. I'm just going to go through all the tests here, and I'll be detailed like what you should know, what you shouldn't know. And I'll try my best to show things in Calculator that are possible in Calculator. Now, the Calculator helps you a lot, but does not solve everything, so make sure you know how to do it by hand also. So let's go through this. I'm going to zoom in a little bit to be a little more clear. Okay. So first, change the radical to a rational exponent. So all you have to do is change this to an exponent that is a fraction. So since 5 is in the square root and 6 on the outside, it would be 6 over 5 here. Over here, it's 6 with 3 as the exponent and 5 as the root. So it'll be 6, 3 over 5. Very simple. Of course, the reverse is true too. So this is 6, 5 over 3. So it'll be root 6 will be on the inside, and you put 3 in the root because 3 is on the bottom here, and then 5 on top because 5 is on the top of the numerator as its own exponent. Our next one, we're going to do r 6 over 5. So we're going to do r's are variable, put that in a root or a radical. 5 is in the denominator, so 5's here. 6 is in the numerator, 6 here. Okay, how to evaluate this. So I'll show this one by hand, and I'll show this one by calculator. So how to evaluate root 3 of 8, or third root of 8. By hand, you could break it down. Since this is a 3, I need a triple. So looks like I have 2, 2, and 2. Well, there's 3 2's altogether, so that just makes it 2. Since there's nothing that's left over or hanging, there's no radical anymore. So it's just the answer 2. Over here, we have 27 5 over 3. So it's going to be 27, and I'll show you on the calculator for this one. So you're going to type in math. So math. And then down here in option 4 is third root. Again, depending on your calculator, it might look nicer or worse, but it'll still work. But it's math option 4 usually. And then I'm going to type in 27 and enter. So I get 3. Then I want to do 3 to the 5th power. That's 243. Just to remind you, another way to do it though, since it's 27 to the 5 over 3, you literally could type 25 exponent. Now, if you have the older calculators that does show a caret, like this symbol right here, you're going to have to use parentheses afterwards. 5 divided by 3, close parentheses, enter, and you'll still get the same answer. So there's 2 ways to do it on the calculator. Maybe the second way is easier because you don't have to look at any math menus. You just literally type it as you see it. We're going on to the next page. So these add your exponent properties. So this is x 3 over 4 and x 1 over 3rd. Since this is a multiplication, what we're going to do is that we're going to add the exponents. So I'm going to make the variables a little, or the exponents a little bigger. 3 over 4 plus 1 over 3. So 3 over 4 over 1 over 3. To make a fraction added together, I need a common denominator. So the smallest common denominator between 3 and 4 is 12. So I'm going to times this by 3 over 3. And I'm going to times this by 4 over 4. So that's going to be 9 over 12 plus 4 over 12. So I got that from here. Then you just add the tops, 13 over 12. Now remember, it was a fraction, so your answer will look like x 13 over 12. It was an exponent, I should say. I think I said it was a fraction. It's obviously a fraction, but it was an exponent, so I have to write it as an exponent. Next one, root 8 times root 4. Because these have the same exact roots and you're multiplying, you can multiply the inside. So the 4th root of 8 times 6 is 8 times 6 equals 48. So that's the 4th root of 48. Now if it's multiple choice, I'm going to make you have to simplify it. So let's see what we can add. We have 4. It's a 4th root, so we need a 4 of a kind. So I'm going to do 12 and 4. 2, 2, 4 and 3, 2, 2. So I have a 4 of a kind here, and since this root is a 4, I need a 4 of a kind. So that gets to leave on the outside too. Now 3, on the other hand, did not have a 4 of a kind, so it has to stay on the inside, and it's going to be 3. So your answer in a multiple choice question is going to look like this. Technically this is true, but answer in a multiple choice question will be 2, 4th root of 3. Over here, this one is a little easier. You just have to simplify first. So root 3 of 8, we did that earlier in the test, so I'm just going to do it, is 2. Now 4th root of 81, what you can do in your calculator, let's say you didn't know that. I'm going to give you a hint, it's 3, but let's say you didn't know that. You could type 81, and since it is a 4th root, I could do to the exponent, put parentheses, 1 divided by 4, close parentheses. And like I said earlier, it's 3. So the top is 3. 3 over 2, that's it. Can't really simplify that. This one, 7 with 6 over 7 divided by 7 and 3 over 7. So when you have a division of exponents, you subtract. So 6 over 7 minus 3 over 7, that equals 3 over 7. Oh, 7. So that's 7, 3 over 7. All right, number 11, perform the indicated operation. These have the same exact base, 4th roots of 6. Because they have the same exact base, I could just add the numbers in front normally. So 2 plus 11 is 13, 4th root of 6. It didn't print well on the paper, but this is 13 root x minus 5 root x. They have the same roots. So it's going to be 13 minus 5, which is going to be 8. So 8 root x. Okay, going on to the next one. So I need this, which is 2x plus 4 equals f of x. 7x minus 3 is g of x, and x squared minus 5 is h of x. So fx plus hx. So I'm going to replace fx with what's up there, 2x plus 4, and I'll put in parentheses just to make it clear. Plus, over here I have hx, which is x squared minus 5. So what I'm going to do is add like terms. 2x, I don't see a 2x, I don't see anything with x to the 1 power on top, so that's going to say 2x. 4, I see a 5 over here, so those get together. Let me put a double underline for that. So 4 plus negative 5 is going to be minus 1. And I have my x squared here. My x squared doesn't have anyone to go with, so it just stays x squared. With that in mind, we're going to do, and that's this, and that's done. So what I'm going to do is just rewrite it in order. If you had a multiple choice question like this, I say if as if I don't know. You will have a multiple choice question like this. It will be in this order. I want to trick you and put this fake order, but it will look like this order. So if you get to here and you see this answer, know that those are the same answer. All right, next one. G of x minus f of x. So g of x is 7x minus 3 minus, and I'll put this in parentheses, I almost forgot, f of x, which is 2x plus 4. All right, 7x minus 2x. 7 minus 2, I'm sorry, this and this is the same term. So 7 minus 2 is going to be 5x. Negative 3 plus, it's negative 3 minus positive 4. Negative 3 minus negative 4, or minus 4, is going to be negative 7. So minus 7. That's already in like descending order, so that's good. All right, a dot multiplication, so we're multiplying here. F of x, which is 2x plus 4, and g of x, which is 7x minus 3. So let's do some foiling. 2x times 7x is 14x squared. 2x times negative 3 is negative 6x. 4 times 7 is going to be 28x. And if you ever think I'm going too fast, just rewind and slow it down. YouTube gives you that option to slow down your speed. 4 times negative 3 is negative 12. Let's see, can we combine any like terms? X squared doesn't have any like terms, but negative 6 and 28 share like terms. So that's 14x squared. Negative 6 plus 28 is positive 22x minus 12. F of h of x. So this is of x, so we're going to put this in and plug it through. Okay. I'll just check. My stream died on my computer. I just want to make sure it was still running. Okay. So h of x is 2x squared minus 5. So what I'm going to do is rewrite this as f of x squared minus 5. And if you don't remember, just scroll back up on the, or go to the video. So now I'm going to take f of x, and let me just write this on the side actually. F of x equals 2x plus 4. So every x is represented here. So if I wrote f of 2x x squared minus 4, I'm going to replace every x with exactly the equation that's in here. So that's going to be 2 parentheses x squared minus 5 close parentheses plus 4. Now I'm going to distribute this 2 to both of these things. 2x squared minus 10 plus 4. Don't forget to distribute. Then negative 10 plus 4. 2x squared minus 10 plus 4 will be negative 6. Circle that, you're good. Let's go on to the next page. Okay. F of negative 2 of h of x. Or f of negative 2. H of f of negative 2. I should say it like that. I apologize. So what I'm going to do first is f of negative 2. Just like the last question, I had a whole equation, so I replace x. So since I have negative 2, I'm going to replace just x with negative 2. So 2 times negative 2 plus 4. Negative 2 times 2 is negative 4 plus 4. Negative 4 plus 4 is 0. So f of 2 equals 0. Now I'm going to take that 0 and replace it here. So f of negative 2, I'm going to replace that with 0. So h of 0. Now I'm going to take that 0 and replace the x squared here. This is how functions work. Whatever I put in the parentheses will replace whatever the x was. So 0 squared minus 5, negative 5. So your final answer for this question is negative 5. You'll see it illustrated in g of 3. So first I'm going to do g of 3, and that's 7x minus 3. So g of 3 equals 7 times 3 minus 3. Well, 7 times 3 is 21 minus 3. 21 minus 3 is 18. So g of 3 equals 18. Now I'm going to take that 18 and plug it for g of 3. And now g of 18 equals 7 times 18 minus 3. 7 times 18 equals 126 minus 3. 126 minus 3 is 123. So your final answer is 123 on that one. Why don't we keep going? Alright, inverse functions. So we have to be able to inverse the function. So the first step for any inverse is going to swap the x and the y. So I'm going to take this equation and rewrite with x and y swap positions. 5y minus 4. Then after that, all I want to do is add 4 to both sides. Or I want to get y by itself. And the way I get it by itself is adding 4 on both sides, allow me to cross this out. So x plus 4 equals 5y. Then I'm going to divide it by 5 on both sides. Now, I can't simplify that in any way. So my final answer is x plus 4 over 5 equals y. Let's go to the next. Swap it again. X equals 3 over 5, y plus 2. Subtract 2 on both sides. X minus 2 equals 3 over 5y. So what I'm going to do is multiply it by the reciprocal, 5 over 3. Multiply this by 5 over 3. So it's 5 times x minus 2 over 3 equals y. Now if I had to make a multiple choice answer, this wouldn't be the final drawing. what I would do is distribute. So your multiple choice answer would look like this. 5x minus 10 equals 3, over 3 equals y. So your final answer would look like this in a multiple choice question. Just so you know, you might get to here and you'd be like, oh, is this it? No, you have to get to there. Next one. Y, x squared minus 11. So I have to swap the x and the y. Now notice the x squared is going to make it a little different. So x equals 2y squared minus 11 plus 11 plus 11 x plus 11 equals 2y squared divided by 2 divided by 2. X plus 11 divided by 2 equals y squared. Now at this point, to get rid of the square, what do? You have to square root on both sides. So that crosses out. So your final answer is going to be square root of x plus 11 divided by 2 equals y. Last one. This time we have the cube root. So we're going to do something like cubing. So let's swap places. X equals cube root of y plus 4 minus 3. First, we want to get the plus 3 on both sides. X plus 3 equals root 3 y plus 4. Now, to get rid of the cube root, what you want to do is cube the power. Now, if I cube it, I have to cube everything, so I'm going to put parentheses here. X plus 3 cubed equals y plus 4. Minus 4 minus 4. Your final answer is x plus 3 cubed minus 4 equals y. That would be your final answer on that one. Graphing and domain and range, okay? So the first one I will graph by hand, and the rest I'll do by calculator. Okay, how to graph this by hand. First, we need to find a vertex, or where our starting point is. To find a vertex, the equation looks like this. Y equals a root of x minus h plus k. Hopefully the h and k looks familiar to you because your vertex is h comma k. And I'm pretty sure when I did do this on the test, I only made you do 2 points. So because this is only 2 points, let's find h of k and then h plus 1 and k plus 1. Okay, so let's see what h is. Since it's negative 2 here, h is always a flip sign. So instead of being negative 2, it's going to be positive 2. And then k over here is just this number here, which is 4. So I found my first point already, 2 comma 4. And let me just graph that real quick. 2 to the right, 1, 2, 3, 4 up. Our next one is that we're going to get the next point, which I will say, let's get 3. So this is 3, and then I'm going to plug in 3 into this. So negative 2, the square root of 3 minus 2, plus 4. 3 minus 2 is 1, so negative 2, the square root of 1, plus 4. The square root of 1 is 1, so we have negative 2 plus 4. 1 times negative 2 is 2, negative 2. Negative 2 plus 4 is 2. So this is 2, 4, and this is 3, 2. So that's 3 to the right and 2 up. Now I'm going to draw the curve. And a line is like that, basically. Oh, I'm sorry. I include this piece. This is not correct. It starts from here and goes like that. That's my fault. It does not include that piece right here. So don't include that in your graph. Okay, so what's your domain and what's your range? So your domain, this is a square root. It is where your x goes. So let's look at the graph. Starting from here, it includes this x and this x and this x and this x. So what we could call it is that x is greater than, because the line is above the x's. Not that it's actually on the axis, but the line is above the x's. So it's x is greater than positive 2, because it hits all the positive roots there. And then this one, our range, the highest it would go, again, you should not have this part in your graph. Let me move it a little bit more in the camera. You should not have this part in the graph. So the highest it goes is 4. And it goes down to 3, 2, 1, and it'll probably go down to infinity. So since it starts at 4 and it goes down, you could say y is less than 4. So that's your domain, and that is your range. Let's look at number 6. Number 6, the square root of x plus 3 minus 1. So now I'm going to show you how to do that all in calculator. So first I'm going to click y equals. I'm going to use my pen to point it out, I guess. So first I'm going to click y equals. Now I'm going to click square root. To get the square root button, it is second and then the square here. So second square. And you have the square root. Mine looks nice. Yours might have parentheses. X is always this button here, which is 1 right and 1 down from the second button. So x plus 3. To get out of the square root, I just go right. Minus 1. Now, to graph it, I'm going to graph it. Now, you see the curve, but that's not sometimes very easy to look at. So what I do is click zoom, and I'm going to do zoom decimal. And wow, that makes it a lot easier to see. I care about what this point is, this last point on the graph. So what I'm going to do is click trace, which is right here. And I'm going to go all the way right. Until I get my last number here. Because if I keep going left, like negative 3.1, I fall off the graph. So I go right, it's negative 3, and y equals negative 1. So what does that tell me? Well, negative 3, negative 1 is one of my points. So I go negative 3 left and negative 1 down. And then let me go to 2. Let's see what 2 is. And 2 comma 0. So 2 comma 0. If you want to look at the points just by itself, you could click second and then graph. That'll give you the table. And you know you should be stopping when you start seeing these errors. So these first two numbers is the ones you care about. So negative 1 and 0. Then I'll make the curve of how it looked like. So when I say domain, it's going to be x is greater than whatever this part is, which is negative 3, negative 2, negative 1, 0, 1, 2. So that's going to be x is greater than negative 3. Notice this x is greater than whatever your h is. Your range is going to be how high it goes up. So it starts at negative 1, 0, 1, 2, 3, and it will go up for infinitely. So y is greater than 1. Okay. So let's go to the next one. Now we're dealing with a cube root. Now the good thing about cube root is domain and range is super easy. I'm going to clear this. To get the cube root, I said it earlier in the video, click math and scroll down to option 4. And you should get cube root. Before I put the cube root, I gotta put -3. So type in first time -3 and then cube root. X minus 1, right, plus 2. Let me graph. Now there's something here. Don't worry about that because that's just a problem of the calculator. We're going to click second table this time. And we want to look for the clean numbers. So the clean number I care about, hey, is 0 and 1. You could even do 0, 1, 2. I guess I should say, you want to usually start at your vertex. So if I were to list the points here, it would be 1, 2. And then I would have found 2. And 2 happens to be -1. So let me graph those 2 points from which I got from the table by doing second table after typing everything in. So that's 1, 2, so 1 right, 2 up. And that's 2, -1, so that's 2 right, -1 down. And it should make a curve like this thing. Kind of like a weird, very weird S that doesn't wrap around. Like the middle part of the S. Now, domain and range for cube roots are the easiest thing possible. Domain for a cube root is all reals. And a range for a cube root is all reals. So we have no issue with either. You could kind of see that because this will go on forever and this will go on forever. And x-wise, it will go to the right forever and it will go to the left forever. Okay, let's get to the next one. Solve. If there's no solution, so state. So we have to get the square root away. So to get rid of the square root, you have to do the opposite of square root. That's squaring. So square both sides. I have 2x plus 3 equals 36. Minus 3, minus 3. 2x equals 33. Divided by 2, divided by 2. X equals 33 over 2. Or that would be 16.5. In a multiple choice question, I think I would leave it as a fraction. But both are useful to know. Alright, over here, we have to get the square root by itself first. So I'm going to do subtract 12, subtract 12. So I have -5 square root of x plus 1 equals -7. No, -10. Oops. Divided by 2, divided by 2. Square root of x plus 1 equals -5. Square both sides. Just to point out, before we did, I think it may have been on the midterm, if you had a square here and it equaled a negative, it will be a no solution. With square roots, you don't have to ever worry, it will always be a solution. So square both sides, so that's x plus 1 equals -5 squared is positive 25. Minus 1, x equals 24. Now, I just want to share with you a test-taking skill. You'll have a multiple choice option with a bunch of numbers. You could take 24 and plug it into the equation here and see if that works. And that can help you out sometimes. So, for example, I could plug in 24 here. 24 plus 1 is 25. The square root of 25 is 5. Why is that messing up, though? Oh, the reason you can't plug it in like that is because the square root is both positive and -5. So you have to plug it in and get -5. So the square root of 5 is not only 5, but -5. Oh, that doesn't change anything. Huh. Maybe scratch that. Just do it out. Because for some reason I'm plugging it back in and I'm not getting the answer. Unless I'm forgetting something. Oh, wow. So good thing I did plug it back in because I made an error. And that's how you can check your work. There you go. I did it on purpose. Look at that. I divided by 2, not divided by 2. I have to divide by 5 on both sides. So now I have to do, that's divided by negative 5 on both sides. So I have square root of x plus 1 equals negative 10 divided by 5 is, or I think it's 10 divided by negative 5. Oh no, it's positive 2. Yeah. So negative 10 divided by negative 5. It doesn't really matter when you square it. It's negative and positive, squares the same. My bad on that, guys. So x plus 1 equals 4, minus 1 minus 1, x equals 3. So why don't we plug it back in and check it to show you that, see, sometimes you might get the answer, and I'll definitely put that type of answer on the multiple choice, and you might get tricked like that. Well, plugging it back in could solve it, or plugging it back in could get you the answer right away. 3 plus 1 is 4. 4, square root of 4 is 2. 2 times negative 5 is negative 10. Negative 10 plus 12 is positive 2. So you can always plug in your multiple choice options. Now the problem with that skill is that if your answer happens to be on letter D, you plugged in 3 numbers right away and you got failures. It could be the advantage that you could plug it in faster than you could solve it out, and maybe you save time there. Next one. Minus 10 minus 10. X minus 5 equals negative 4. Square both sides. X minus 5 equals positive 16. Plus 5, x equals 21. Now let's plug it in to check. 21 minus 5 is 16. The square root of 16 is positive 4, and 4 plus 10 equals 14. So maybe there you're like, Mr. Tobal, that doesn't work. But remember, the square root of 16 is not just positive 4, it's also negative 4. So it's negative 4 plus 10 equals 6. So that's a way you could check it. Okay, this one. So x minus 2 equals 2/3 equals 9. So to get rid of that x minus 2 to the 2/3 power equals 9, what I can do is multiply or raise everything by the 3/2 and raise this by the 3/2. If you remember, 3/2 is the same thing as square root the 2 and 3. The square root of 9 is 3 to the 3rd power, and 3 to the 3rd power is 27. So x minus 2 equals 27, plus 2 plus 2, x equals 29. Next one, I kind of overlapped this, so I'll rewrite it, or wrote over it. X plus 6 minus 2 equals negative 3, plus 2 plus 2. Cube root of x plus 6 equals plus 2, negative 1. Cube both sides. X plus 6 equals, cube of negative 1 is still negative 1. Minus 6, x minus x equals negative 7. Plug it back in and you should get it right. Okay, graphing. You definitely need to know the graph. Okay, graph these. So I'm going to show the first one by hand and the rest of by calculator. Alright, so how do you graph 2x minus 2? Well, what we can do is try to plug in numbers. The equation for a graph of this type, let me just check, what was it again? Oh, I remember. Y equals, or f of x equals, y equals a times b to x minus h plus k. Now we're looking for not the vertex, but we call it the asymptote. The asymptote happens to be h comma k. And notice, see how it says minus h? It's going to be the opposite. So in this case, negative 2, so that's going to be a positive 2, comma, k, which is just going to be 0 because you're adding 0 to it. So if I have 2 comma 0, I want a point above and below it. So this is let me make it like a table, x, y. So I want something smaller than 2, which is 1, and something bigger than 2, which is 3. So let's plug that in. So let's plug in 1 first. So 2 to the 1 minus 2. So that's 2 to the negative 1 power. So that's 1/2. Remember, anything to the negative power you bring down. So that's 1/2. I'm going to change that to the decimal, so that's 0.5. Let's plug in 3. 2 to the 3rd power. 3 minus 2. 2 to the 1 power. 2. So 2. I think on your original test I said only 2 points. So because you only want 2 points, just do the first number, your h and k, and then the second number, which is 3 and 2. So we're going to circle those. That's the ones you care about, actually. So if I said 2 points on your original test, I'll say 2 points on your final. So I'm going to go 2 right and 0 up, and I'm going to go 3 right and 2 up. Now how this should look like is going to look something like this. Oh shoot. Something like that. Did I do it right? Where am I making a mistake? Oh, I made a slight mistake. When you plug in 2 into the equation, 2 to the 2 minus 2 will be 2 to the 0 power. Now what's anything to the 0 power? 1. So this point should be 1. That's why. So my graph is a little higher up. There you go. So a little higher up, not underneath it. Let me just quickly graph it into the calculator just to show how it should actually look. So just above the line. At 1 is at 0.5, we found that earlier. At 2 it should be at 1, that's good. And at 3 it should be at 2, okay. So what is the domain and range? Domain for these are always all reals, so you don't have to worry about that. The range for this is going to be above what our k is. That's where our k is useful. I'm mistaken. So it's not h plus k, but it's h plus 1, my fault. So your range is going to be above what k is. So since it's plus 0, it's going to be y is greater than 0. Okay, so let me teach you how to type into your calculator. Let's do it with the next one. 2x squared, or 2 to the x power plus 3. So I'm going to click 2 to the exponent. The exponent button is right here above the division. To the x power, I have to click right to get off that, plus 3. Okay, so I'm just going to graph to see how it looks. It's pretty high up. If you have a situation where it's not in the zoom window, you always could go back down to zoom, click zoom in the middle, and then click standard. Standard is like a 10 by 10, I believe. So it'll show it up a little better. But you still can't really read numbers, and when you trace, it's like all decimally, which is not very useful. So because of that, and I'm sorry for the lights. Because of that, what we're going to do is click second table. Now I'm going to go down to where I see a normal point. Your guess is going to be, your normal points are going to be at wherever h is. And since h is 0, it's going to be at 4. So I have 4 here. So let me put that point down. 0, 4. and I have 1, 5. Oh, cute, and I could keep going, but so 0, 4 on this table would be 1, 2, 3, 4 to the right, and 1, 2, 3, 4, 5 up, and this is 5 to the 2. Wait, which one am I looking at? 0, 4. I'm making a mistake. So 0 right and 1, 2, 3, 4 up, 1 right and 1, 2, 3, 4, 5. Make a curve. Okay, so my asymptote. Well, let's look at this. Domain, range, and asymptote. The domain is 2x plus 3. The domain for all these ones are always all reals. The range is going to be what my k is. If you don't know what your range is and you don't know it's your k, keep scrolling up and notice something. Notice how it never passed 3. Now it just says 3 because it's like 3.000000000. So your calculator just says, it's basically 3. But notice how it never gets underneath 3. So your range is y is greater than 3, since it never goes below 3. And look how it looks in the picture. Notice how your graph never goes below 3. Your asymptote is what we said earlier. 0, 4. Oh, no. It should be h plus 1k. So 0 plus... Oh, no. It should be k plus 1. Oh, so it's 4, yeah. 0, 4. Here, it should be plus 1 in the original. So, because it was k plus 1, since k is 0, it's just plus 1. Okay. Let's go to the next one. I'm going to do this one, and then I'm going to skip the next one on this page, simply because I do want to finish before 2 hours, and I'm already at 47 minutes. But also because I'm not going to give you a harder one like number 4. So let's click y equals. Let's type that in the calculator. Parentheses, 2 divided by 3, close parentheses, to the power of x plus 2. Okay, I don't really need to see the graph, I just care about the table. So I care about it at 0 and 1. And why does it look like this? Oh, I know why. So let me see. Can I do... Let me see something. Because if I can't do this, then I'm just gonna... Oh, okay, cool. And let me be genuine, actually. I'm not gonna give you one with fraction. So I'd rather, instead of making you bother to learn it, let's skip it for now. So 3 and 4, you're not going to do a fraction graph on the calculator on the test. So don't sweat it. These though, yes, definitely. So y equals, now the E button. So I got to type 3 first. The E button on your calculator is all the way down to the LN button, but it's the option. So you gotta click second, E. Oh, sorry, I missed the second one. Click second, and then E. And remember what ln and E's relationship is later to the x. Okay. Now I want to see at H, which is at 3. So I want it at 0 and 1. X and Y. So at 0, it's 3. And at 1, it's going to be 8.15. So 0, 3, that's up here. And 1 and 8.5, which is up here. Make my curve. Let's graph it just to see how the curve looks like. Hey, it looks like what I thought it was. Maybe a little lower. Curve it up. My domain is all reals. My range, there's no k here, so my range is y is greater than 0. My asymptote is just 0, 3. Alright, let's go to the next one. F of x equals negative 2x. Type that all in your calculator one more time. Negative 2 second ln, so down here underneath log, x graph. Hey, it looks upside down. Remember, since it's negative, it's upside down. Let's get the table. I only care at what h is and at h plus 1. So x, y. That happens to again be at 0 and 1. Not happens. I think I purposely did that to make it easier. So at 0, it's negative 2. And at 1, it's negative 5.43. 0, 2, 1, negative 5.43. A little past 5. Make the curve like that. Your domain, all reals. Your range is going to be, there's no k, so it's going to be y is less than 0. Your asymptote is going to be 0, 2, 0, negative 2. Okay. Let's go to the next page. Is it growth or is it decay? Our favorite game. So, it's actually really easy. This number that's in the parenthesis, if x is between 1 and negative 1, or well, I shouldn't say x, I should say it's b. So if b is in negative 1 and 1, so this number is between negative 1 and 1, it's a decay. If it's anything else, so bigger than 1, so b being greater than 1, it's a growth. So this is less than 1, decay. This one being greater than 1, growth. Now for e's, it's when the exponent is. So e to the negative power is going to be a decay. E to a positive power is going to be a growth. So another decay and another growth. Very simple. Alright, literally have to use the calculator to solve the expression. Make sure you have a calculator on the finals. You can't do it without it. So, second ln, it's on the calculator, on the screen I should say. Second ln, you should make e, to the 5th power, times 5. Hey, that's 148.41. If I roll a multiple choice question, it'll be 2 decimal points. Next one. Second ln. And we're looking for negative button, just in case if you don't know, is this one right here. So negative 0.5. So that's 0.61. In the calculator, I would round out to 0.61. And the last one, second e. To put a square root, you click second and then the square button. 5. Enter. 9.35. 9.36. You don't have to sweat. I would not put in a multiple choice question, 9.35 and 9.36, and make you choose. That would be unfair. And my multiple choices, there will be only one right answer to the situation. There won't be like one more right than the other, okay? All right, simplified expression. This is our property, our exponent properties. So if you're multiplying, you add. So e to the 4th plus e to the negative 2, it's e to the 2nd. Because 4 minus 2 is, or I should say 4 plus negative 2 is 2. So e to the 2nd. Hey, we're distributing. So e to the 4th times to the negative 2 is e to the negative 6. Oh my god, it's multiplication. So it's e to the negative 8. For E, you don't have to move it underneath 1. It would look like this in a multiple choice. Over here, let's first do the normal numbers first. 2 divided by 4 is 1/2. E to the 4th divided by e to the 2nd. When you divide exponents, you subtract. So that's e to the 2nd. Actually, it would look like this. E to the 2nd over 2. Next one. Multiply normally. 3 times 2 is 6. Then you have e to the 3x times e to the 7x. So 3x times 7x, you add them. So 3 plus 7 is 10. So e to the 10x. So that's how your answer is going to look. Do not do 21x. That's definitely going to be one of your fake answers on your multiple choice. Okay, so I give you this equation right next to the question. The key thing here to know is that, excuse me. The key thing here to know is that R, N, and T are different things. R is your rate. Now you have to move it and change it to a decimal though. So you got to move the decimal twice to the, if you get a percent, let's say, like 10%, you got to move the decimal twice to make it 0.1. You need to change it to a decimal or you won't get the right answer. And trust me, I'm going to put one of the fake answers as if you didn't. N. N is your how many times per year. Number per year. Now you know what N is going to be important because in the continuous one, I didn't put it, on the continuous one, there's no N because you're going on for an infinite amount of times throughout the year. So N has to be the one that means how many times a year. And then you have T. T is just time, typically in years. So let's do this quarterly. So you deposit $5,000 and it earns 3% annual interest, 5 years, and then it's compounded, in this case, quarterly. So principal is what I put in, which is 5,000. My rate is the percentage, so it's 3%, but I need to change that to decimal, so 0.03. My N is how many times a year? Quarterly, think of a quarter of a dollar, so that's 4 times a year. And how many years was that? Well, time. So how many years is that? 5 years. That's from here. All right. So let's do it out. A equals, and I'm just replacing all the variables here. A equals 5,000 parenthesis 1 plus, in this case, it's going to be R over N, so 0.03 over N, which is 4, to the second power 4 times 5. Times N times T, which is 4 times 5. So, how would I type that in the calculator? 5,000 parentheses 1 plus 0.03 divided by 4, close parenthesis, to the power of 4 times 5. For most calculators, though, I would actually put it in parentheses, so 4 times 5. Enter. The money you would earn is 5,805.92. Because it's money, you stop at the cent. So what about monthly? Monthly is only changed a little bit. P is still 5,000. R is still 0.03. R. T is still 5 years. But N is going to be not anymore 4, but 12. So the amount equals 5,000, parentheses 1 plus 0.03 over 12 times, this times 12 times 5. So the 12 is the only thing that's different. Now, to be honest, it's not going to change your question too much, or change your answer too much. This is on the screen? Good. 12 times 5. And you can, it's also like, I could just type in 60 if I know 12 times 5 equals 60. Maybe it makes it less errors on your calculator. 5808.08. There you go. Now continuously you just use E as in the normal number E. So A equals, P is still 5,000 times E. R is still the same rate, 0.03. And T is still the same rate, which is 5 in this case. Yes, 5 years. So, just to make sure you actually see me type it in, I guess I'll put it this way. It is going to be 5,000. Actually, let me do it this way so you can actually see the screen too, or the paper. Second, EX, 0.03 times 5. It assumes you're multiplying, but you could put the multiplication symbol between 5,000 and E. I think it's going to assume you're multiplying because it's a variable. So that one, again, not so much different. 5809.17. All right, next one, logs. Logs was a tough time, but I think you guys can handle it. So how do I rewrite this in exponential form? All I do is take my log 2 and slip it right underneath the 5. So that's 32 equals 2 to the 5th power. What I do is log base a, so as I slip it right underneath negative 2. So that's 1 over 64 equals 8 to the negative 2 power. How to rewrite in log form. What I do is take this 3, that's the base of an exponent, and slip it under here. But instead of being an exponent 3, it's going to become a log base 3, 81. What I'm going to do is take this 5 and slip it under here. So 0 equals log base 5 equal of normal 1, a normal size 1. Okay, those are super straightforward. What you do is whatever the base is. So if it's a log base, you change it to an exponent base. If it's an exponent base, you change it to a log base. Evaluate. So how do I evaluate this thing? So I'm going to set it equal to x, let's say. And I'm going to take this thing and bring it over here. So I have 3x equals 1/3. So 3x equals 1/3. How do I solve that? Well, I have to think. 1/3, that's me moving it down. So x must equal negative 1 because I'm moving it down a fraction. But let's say, God forbid, you didn't see that clearly. We got the calculator for us. So what we have to do is something called the change of base formula. So let's see, the top number here is 1/3 and the bottom number here is 3. Like the normal size number is 1/3 and the base is 3. So what I'm going to do is do log of 1/3 and close those parentheses. Divided by, and the log button is right here, by the way, where my pen is. Log of, in this case, is going to be 3, because 3 was the base of the previous log. And it seems like we got the answer I wanted, which is negative 1. I'll do some more change of base later. Equals x, so bring it over. So 12 to the x power equals 144. I even could see that's equals 2. Log 1000. If you don't see a log on the base, you have to assume it's 10. So log base 10 equals 10,000, or was this 1, 2, 3, 4, 10,000, yeah. Equals x. Bring that over. So 10x equals 10,000. That's 1, 2, 3, 4 zeros. So that's 10 to the 4th power. So x equals 4 on this one. ln of 1. If you know what ln is e. So that's log e, I could say. ln of 1 equals x. So I'll bring e over. 1 equals e to the x power. Now you're probably wondering, Mr. Tobal, how are you going to do e to the x power? You can't do e with a calculator. Well, what exponent could I put in that makes any number into 1? That's right, x equals 0. Anything to the 0 power will make it 1. Again, I'll do the calculator on the ones where we're forced to do calculator, which is later in this question. Ooh, give us the inverse of these functions. So, to get the inverse of any function, what you have to do is switch x and y. So I'm going to switch x here, equals log base 4 6 y now. Now I need to get rid of the log 4, so just slip it underneath the other side. So it was a log before, so now it becomes an exponent, or exponent base. So 4 to the x power equals 6y. Then I divide it by 6 on both sides. 4x to the 6 divided by 6 equals y. You cannot simplify this because this is 4 to the x power, so you can't simplify that to 2/3. Trust me, I'm going to put 2/3 x on a multiple choice question like that. So don't simplify it. Next one. E. Well, first let's swap the x and the y. So x equals e, y over 5. E, I have to move it over to get rid of him. So e is going to become log. Log e is the same thing as natural log, or ln. So ln of x equals, I think it's y divided by 5. So I could do times 5, cross this out. 5 ln x equals y. Okay. Give at least 3 points for this. I showed this how to do on hand, and then I retracted it because it's so hard to do by hand. So I'm going to cheat and use the calculator. I'm not cheating. I'm using the tools that are available with me, which is the calculator. Now my problem is it's a log base 2, and I only have a log button and an ln button. So I have to use the change of base formula. So log base 2x is the same thing, and that's not on camera, I'm sorry. So log 2 base x, or base 2x, is the same thing as log of x over log of 2. Now you could do that with any number, just like I did on the previous page, or the previous 2 pages. So let me type that in, as is. So log of x, parenthesis close, divided by log of 2. Now I could graph that, and it's graphed, but it doesn't really help me see. So what I'm going to do is click second table. And you see all those errors? I don't want to look at those. So I just want to go to the ones that are important to me. So I see a 1, a 2, and a 4. And I'm going to pick 4 on purpose just because it's a clean number. You could pick 3 if you want to. But x, y, 1, 2, 4. That's 0, that's a 1, and that's a 2. And that's super easy to graph like that. So 1, 0, 2, 1, and 4, 2. Make my curve. Hey, that's 100% right there, okay? I think on your test, I'll only make you use 2 points. I know, what am I saying I think? I know for a fact I'll only make you use 2 points, so don't only worry about 2 points. But that's how you get those points. Second table. Don't forget the second table. Those things will get you points. Oh my god, expanding. I remember this was a doozy for some of you guys, so why don't we try our best? So when you see a multiplication going on, you could change that to a addition. Think how the exponents is. When you multiply something, you add them. So what I'm going to rewrite this as is a log base 6 of 3 plus log base 6 of x squared. This is technically a right answer, but it's not expanded all the way. So if I had a multiple choice, I would not put this option in because it's technically correct, but it's not expanded all the way. I have an exponent 2 here, Now, exponent, if you remember, when you raise an exponent to an exponent, you multiply. So here, I'm going to change it to a multiplication. So log base 6 of 3 plus 2 log base 6 of x. At that point, I am done. This one sadly can't be done on calculator. All right. Next one is going to be ln of 5a divided by b. So when you see a division, it's like a subtraction. So ln of 5a minus ln of b. And this is a multiplication, so it's like adding. Ln of 5 plus ln of a minus ln of b. And circle that, and you're good. Sweet. Let's go to the next one. Log 9 minus log 3. Condense it. What did I just say? The subtraction was like division. So this is the same thing as log 9 over 3. Now, what is 9 divided by 3, you say? Log 3. So your answer will look like this. Next one. ln x plus 3 ln y, ln, should be ln, y plus 5 ln z. So what I want to do is take all these numbers that will be multiplied and move on top first. So ln of x plus ln of y to the third, excuse me, plus ln z to the 5. Since these are all pluses, I can multiply. So ln of x, y to the third, z to the 5. Yeah, that was really easy. Okay. Hopefully that feels easy. We could always do more practice of that, but I might have rushed through it, but that's why the benefit of the video, you can scroll back and watch anytime. But let's keep going. Let's see, we're at 4.4. I forgot how high we get up to. After 7, so we still got a little bit. Log 4 base 4 of 7. So I'm going to use the change of base. So log base 7 and log, not base 7, just log 7 and log 4. Remember, the smaller number will always be on the bottom. This one you're forced to use a calculator. So log 7 divided by log 4. Oh, I forgot to close the parentheses. I would have got that wrong. So log 7 divided by log 4 is 1.40. Or 1.4, it could have been like that. Next one, log 9 over 11 9, so that's log of 9 over log of 11. So I'm just going to be cheap and do 9 and 11, 11. Oh shoot. Whatever, let me type it all the way out. Log 11 divided by log 9. Hey, that's 1.09. Okay, so you could use a change of base formula to solve these equations. I think I will mention on the test when you see those questions to use change of base formula so you don't get too stuck. These guys, I'm not giving this type. I'm not giving this type. I really did like those, but and I'm not going to give that on the final because they take a lot of work and a lot of thinking power that I don't feel like it's fair on the final. So cross those out. Number 20, 4x equals 13. So 4 to the x power equals 14. So how do we get rid of the 4? Well, you got to slide it over. It was an exponent base. So the exponent base is going to become log base 4 to 13. Alright, log base 4 to 13. How do I solve that in my calculator? Well, you do log of 13 divided by log of 4. Very important. Please do not type in log of 13 divided by 4. You will get it wrong, okay? And trust me, if it's a multiple choice question, I'll put that fake answer in. So, log of 13 divided by log of 4 equals 1.85. So that equals 1.85. Okay. Twenty-one. Log base 4, since these are exactly the same, I could cross these out. So I just have 5x minus 16 equals 3x. Plus 16 minus 3x, 2x equals 16. Divided by 2, divided by 2, x equals 8. Do that really quickly. Just go back if you didn't understand. All these have the same base, but I have to condense these first. I remember a lot of people didn't condense this, and they got that wrong. So I'm going to condense this. So it's going to be log base 2, 3x equals log base 2, 6. From that point, cross out those logs. 3x equals 6. From that point, divided by 3 on both sides, x equals 2. This is tiring. I can imagine how much you have to study, guys. Sorry you have to study so much. But I hope this video helps you in your studying a lot. Let's keep going. Y equals 2.5x. So y equals 2.5x. Is that directly, inversely, or neither? Hey, that's being multiplied to x, so that's direct. Hey, that's x in the division, so that's inverse. Oh, wait. X is on top. Because x is on top, that's actually, there's a plus, actually, here's what really matters. There's a plus 10 here. Because of the plus 10 there, it's neither direct nor inversely. You cannot have a plus 10. There should be no plus or minus there. So that is neither. So anyone who is about to type in the comments, don't worry, I realized. Over here, 7 divided by x equals y. This is divided by x, so that's inverse. Okay, these ones. Definitely know these ones because they're going to be, I literally can visualize the 2 multiple choice questions or 3 multiple choice questions I gave you this. Okay, y varies inversely with x. When x equals 12 and y equals 6, find when x equals 4. It's not broken up like this for you on the test. It's just a multiple choice answer. So, we have to still find y equals inversely. So that's a over x. So, 6 equals a over 12 times 12 times 12. A equals 6 times 12 is what? Somebody help me. Good, 72. Are we done with that? No, because then we want to find y when x is 4. Oh, I wrote that twice, funny enough. I wrote that twice on this. I just said it twice. So y equals x equals 4. So y still equals a over x. So y equals 72 over 4. 72 divided by 4 is going to be, somebody help me, calculator will help me, I guess. After doing this for, it seems to be, what do we got, hour 17? Yeah, you start getting a little woozy, so I can only imagine what you guys feel like 8th period during math. But y equals 18, that's where we at. Numero 5. Z varies jointly with x and inversely with y. When x equals 8 and y equals 6, z equals 12. Find a constant, which is a. Okay, so find the constant. So z varies jointly with x, so that's x times a, and inversely with y, so y is being divided. Find when x equals 8 and y equals 6, z equals 12. So 12 equals when x equals 8 and y equals 6. So I could do times 6 on both sides. So that's 72 equals 8a. Oh, it's the same thing over there. Divided by 8. 72 divided by 8 should be 9, right? So a equals 9. Find z, and it's still this formula. So we're going to replace xa and y. When x is 5, so 5 times 9, and y equals 3. 5 times 9 is 45, divided by 3. That is 45 divided by 3, 15. So z equals 15. Sadly, this one's not easy to plug in backwards like the other algebra ones. But, yeah, you just need to know how to do this. Oh, these guys have a couple. These have a good representation, like a little bit over maybe. So let's simplify as best as possible. So let's cancel these things out. See, I have a b and b3 here. So I could cancel one of these out and make this b squared. Let's see. I have a 5 and a 10, so I could cancel the 5 into 1. And I could cancel the 10 into a 2. I have a 2 and a 4, so reduce this to 1. And reduce this to 2. So let me rewrite what I have right now. 2 times 2 is 4, a squared c squared over a b squared. Oh, I still have an a, so I can cross this out and reduce this to 1. So 4ac squared. Oh, and I had a c here. I'm sorry, I had a c here. So c, cross this out, reduce this to 1. So your final answer is 4ac over b. Oh, I did that off camera a bit. I apologize. Take a second to look at it. $6.52. Okay. Next one. Let's cancel out what looks exactly the same. So x plus 7s look the same. So I'm going to cross those out. Now I have x plus 9 over x minus 9. These don't look the same. Because they're not exactly the same, you cannot just cancel them. So you're done there. Next one. Ooh, factoring. Factoring is pretty fun. What multiplies to negative 6 that adds up to negative 1? Well, that's negative 3 and 2. So this is x minus 3 and x plus 2. If you don't know how to factor, please look up another YouTube video. I'm not going to go over that in this video. So, negative 10. So negative 10, that adds up to negative 3. So that is 5. Negative 5 and positive 2. So x minus 5, x plus 2. Does anything look exactly the same? The x plus 2's do. So it's x minus 3 over x minus 5. Next one. X squared plus 5x plus 4. So what multiplies a 4 that adds a 5? X plus 4 and x plus 1. So that's this one on the top left. Bottom left. X squared plus 2x plus 1. What multiplies 1 that adds to 2? X plus 1. X plus 1. Times. We have an x plus 1 here and an x plus 4 here. X plus 1, x plus 1, cross those out. X plus 1, x plus 1, cross that out. X plus 4, x plus 4, cross that out. That ends up reducing to a whole number 1. Isn't that nice when it reduces down to a whole number 1? Next one. Let the camera focus and then I'm ready to start. Come on. There we go. Okay. X cubed. And my camera so unfocuses. Which is annoying at least. Alright. X cubed plus 2x squared minus 64 divided by x squared. So when you see a division here, what you have to do is flip this the second equation. So x cubed over x squared minus 64 times x plus 8 over x squared. Now, x squared minus 64 could be simplified because they're perfect squares. So if you want to factor this, this is or if you need to look this up if you don't know, it's the sum or the difference of two squares. This difference of two squares you would search. So this is the same thing as x plus 8, x minus 8. Notice they're both the square roots. X plus 8, cross those out. Those are the same. X squared, x third, these are 2 here, and there's only 1 left over, so it's just x. So your answer is x over x minus 8. You cannot simplify this. Trust me, I'm going to put an answer on the multiple choice, something like that. And somebody's going to get it wrong, and I'm going to be really mad. Just x over x minus 8. Or I'm going to be disappointed at least. Especially since I do this, and hopefully, I don't think anyone has logged in to watch it live, so it is what it is. Divide, so times it on both sides. X squares minus 9 over x minus 3 times, I gotta flip this, x squared plus 7x plus 10 over x squared plus 8x plus 15. What multiplies this 10 and that adds to 7? X plus 5, x plus 2. What multiplies 15 that adds to 8? X plus 5, x plus 3. X squared minus 9 can be simplified to x minus 3, x plus 3, because they're both perfect squares. X plus 3, cross those out. X plus 5, cross those out. X minus 3, cross those out. The last thing you're left is x plus 2 on the top right. X plus 2. Whew. Next one, we need common denominators. So, to change this 4x and 8x to match, 4 has to become 8, so I'm going to multiply this left one by 2. So that's 10 over 8x minus 4 over 8x. 10 minus 4 is 6 over 8x. Now, I could simplify this by 3 over 4x. The reason I can simplify these and not simplify something like this one before, there's a minus here, so this is like in some invisible set in parentheses, and thus you can't just rip it out of the parentheses while giving everyone. Here, there is no invisible parentheses, it's just 8 times x. So because it's just 8 times x, I can reduce the numbers normally. Next one, let me rewrite this, 6 over x plus 4 over 3. So I need to make this equal to 3x, so I got to times this by 3 over 3. And I got to times this by x over x. So now I have 18 over x, and because I zoomed this in, it's like too zoomed in and it's too little space to work on. 18 over 3x plus 4x over 3x. So that's 18 plus 4x over 3x. Can't do anything about that, circle. Oh man, we're almost done. I'm very happy for myself. Solve. So if you see this, it's plus over 1. So I'm going to cross multiply. So cross multiply like the butterfly method. So 2x minus 3 equals 1 times 2x plus 2. That doesn't really change anything. Make sure to distribute. Some people don't. 2x minus 6 equals x plus 2 plus 6 minus x minus x. X equals 8. Ooh. Next one, number 15. Over here and over here. Cross multiply. So 5 times x plus 3 equals 6x. So that's 5x plus 15 equals 6x. Minus 5x on both sides. 15 equals x. For some reason I remember this one being 1. Okay. This has to all match. So I'm going to make this to 6. So I'm going to times this one by 2 over 2 and make this one match by 3 and 3. So 2 times 2x is 4x over 6. Plus 3 times 1 is 3. Equals, I didn't have to do anything here, so x over 6. Since these are exactly the same on the bottom, I could cross those out. So I have 4x plus 3 equals x. Subtract 3 minus x minus x. I have 3x equals negative 3. Divided by 3, x equals negative 1. Okay, to make this match, I needed it to be 2x on the bottom. So I got to multiply this by x over x. I got to multiply this by 2. I got to multiply this by 2. So that's 3x plus 2 equals 2 parentheses x plus 4. Now since the bottoms match, I don't have to rewrite them. 2 and 2. 3x plus 2 equals 2x plus 8. Subtract by 2. Subtract by 2, subtract 2x, subtract 2x. X equals 6. Is that negative or positive 6? Yeah, that's a positive 6. Alright. Hey, we're almost done. This stuff we didn't get an actual test on, so this is important to listen to. At looks like an hour and 30 minutes in. This is important stuff to listen to because we never had a test on this. Okay, arithmetic. Arithmetic, think of adding. Geometric, think of multiplication. I don't have any way to associate the two, geometric and multiplication, but arithmetic is adding. So let's see what's happening here. This is a plus 5, a plus 5, a plus 5. Hey, you're adding 5s to everything. So since the pattern is plus 5, that's arithmetic. Arithmetic. This is 150. Now 150 is divided by 2. Or divided by 2. Or times by 1/2. 50 to 25 divided by 2. 12.5, that's divided by 2. Since I'm dividing, which dividing is just another version of multiplying, that's geometric. So that's a geometric here. Next one. This is a famous sequence. 1, 1, 2, 3, 5, 8. I think if it was somebody mentioned it in class, if a Fibonacci is one of the famous ones. It is famous because it takes the one that added before it. So you add, this is 1, you add 1, you add 1, you add 2, you add 3, you add 5. And what's fancy about the Fibonacci sequence is when you take the sequence, it's the sequence of the sequence. As in this pattern is the same pattern here, the shifted one. Which is cool, but Fibonacci is neither geometric or arithmetic, so it's just neither. But a cool thing. Cancel these out. You're not going to do these. I will not give you those on the midterm. This one, find the sum of 6, this thing. So, how to do this? We're going to click, actually, let me check on my calculator by myself before I do it. Because I could just be wrong. Where is the... Actually, I don't have a clue where it is, actually. I should have checked this before I did this video. Does anyone know? Can you type it in right now? No, I only have one viewer, and I think that's me. So, no one's going to help me, so let's see. I am 100% sure you could have put this in the calculator. I just don't remember where. No? Oh, yeah. No, wait. Oh, okay. Okay, I remember. Okay. It was a little complicated, but we could do it. So, you're going to click STAT. S-A-T. I'm sorry. S-T-A-T. Stat, which is right here. And I gotta make sure this is actually in the view. Let me zoom this out. So you're going to click Stat right here. And I'll use the pen so my finger doesn't block everything. Click Stat. You're going to roll right. We're looking for the sum. So, wait, did I fix that? Oh, I'm sorry. Second stat, my fault. And you're going to go down. And you see how it has option 5? It says sum. And what are we looking for? The sum. Okay, I must have messed up. Huh. Alright, I'll do it by hand. Because I can't remember how to do it by calculator. I'll make the number small so you can do it by hand too. Alright, so it's N1 through 6. So I have to do from 1 through 6. So I'm going to plug in 1 here. So 3 times 1 plus 1, that's 4. Now I'm going to plug in 2 here. 3 times 2 plus 1 is 6, 7. I'm going to plug in 3 here. 3 times 3 plus 1, 9 plus 1 is 10. Now notice the pattern's 3, 3, 3. The pattern's always going to be this number in front of x. in this case. So 3, 3, 3, or it should have been n. My fault on that. So the first 6 numbers is 4, 7, 10, 13, 16, 1, 2, 3, 4, 5, 19. So 4 plus 7 plus 10 plus 13 plus 16 plus 19. So that's 69. So 6, yep. All right. Next one. How do I do this, Mr. Tobel? That's pretty easy. From 1 to 4. Plug in n for 1 to 4. So 1, it's going to be 2 to the third power, 1 minus 1. Well, 1 minus 1 is the 0 power. Anything to the 0 power is 1, so that's 2. So your first value is 2. Plug in 2. So 2 is 2 to the third power. 2 minus 1. 2 minus 1 is the 1 power, so that's 2 times 3. That's 6. Let's plug in 3. So 2 to the third power, or 2 times 3 to the 3 minus 1. 3 minus 2, 3 minus 1 is 2. Okay? So 3 to the third, 3 to the second power is 9, so 2 times 9 is 18. Now notice the pattern, times 3 times 3. So the number inside the parentheses, in this case in a geometric sequence, is going to be the pattern. So 3, 3. So 2 times 3 times 3 is 18. Then we got to get the next one, which is times 3. 18 times 3 equals 54. So 54. So 3, 3, 3. And then we're going to add that together. 2 plus 6 plus 18 plus 54, which is 80. Alright. Oh, these we could definitely do in the calculator. So I'll show by hand and then do by calculator next. Whenever my phone wants to focus. Is that in focus? That looks kind of in focus. So let's keep going. 4 exclamation point. That's the same thing as 4 times 3 times 2 times 1. 4 times 3 times 2 times 1 is 24. I'm pretty good at math, I guess. Let me zoom in so it's focus actually. Okay. Next one. 6 exclamation point. How do you do exclamation point in the calculator? Very easy. Click math. I didn't show on the calculator. Click math. And then it should be option. Oh no, you got to go. Let me zoom this up. So then you got to go to option probability. So that's 1, 2, 3 over here. PROB. Some say it's PRB. Option 4 is exclamation point. Oh, I got to type in the number. So it's 6 exclamation point. That's 720. As you type it in the calculator. 11p3. So how do you do 11p3? By hand, it's 11 times 10 times 9. You go down 3 numbers. So you have 3 numbers here. 11 times 9. 11 times 10 times 9, that's 990. Over here, 12p4, to type that in, you do the same thing. Math, go all the way right to PRB, and then you got to do NPR. That's the second option. So 12 and 4. Some calculators, you need to type it in first before you go. 11880. Next one, C. So C is 10 times 9 over 2 times 1. So that is 90 over 2, which is 45. Over here, 12C5. So 12C5. We're going to do 12, math, probability, and CR. So that's the third option. And then it's 5. Whoa, excuse me, 5. So that's 792. 792, okay? And that's how it looks like in the calculator. Okay, I'm going to do these all in calculator, but I'm just going to talk about how you tell which one is which. So, there's a gold, silver, and bronze. Each position is particular. Particular starts with a P. 8 people are racing in total. 3. Remember, the bigger number first. A pick 3 is 8 times 7 times 6, which is faster to type it in the actual P thing. 336. In the deck cards, how many from 1 to 10? So you have 10 cards in total. So 10 cards in total. How many 4-card hands you have? Now, in a hand, like in a poker hand or something, it doesn't matter if the ace is on the left or the right of the card. The position doesn't matter. So I don't care about the position. Let's see. So 10C4, that's going to be, that's probably easier to type in the calculator. 10 math, go to probability, NCR, 4, enter, 210. Bob needs to pick 3 out of the 15 students to get markers from the front office. So 15 students, 3. It doesn't matter if I pick you first or last, you're all going at the same time. So 15, choose 3. 15 times 14 times 13 over 3 times 2 times 1. So that's 5 times 7 times 13, 455. Out of 30 students, you need a president, vice president, and secretary. Because the positions are particular, there's 3 different positions, it's P. So 30, P3, because there's 3 jobs, president, vice president, secretary. That's 30 times 29 times 28 equals 24,360. A lot of ways to fill it up. Last one. How many ways you could do copier? So there's 6 letters, so it's just 6 factorial. 6 factorial is 720. I'm going to be genuine. Ignore this. You're not going to have a problem like this in the Word. Put an X on it, okay? Last one. The things, the matrices, you add them. Okay, I'm running out of battery, that's why I'm a little rushing. And now it's going to be unfocused and it's going to die on me most likely, but which kind of sucks, but so when you add, you just add normally, like add each position. So 8 and -2 if this thing doesn't work. If this thing wants to work one day. Okay, zoom in molecularly, but so 8 and -2, you got to add that together. So 8 minus 2 is 6 on the top left. 6 plus 10 is 16. -3 plus 2 is -1. And 4 plus 4 is 8. Next one. This 8 minus 8. So 8 minus 8 is 0. 6 minus 6 is 0. -3 minus -3 is 0. 4 minus 4 is 0. That was really uncreative of me. Especially if the light's going to die like that. Okay. Last one. Uh-oh. Battery's off.